we've done enough of the theory behind what's going on. Let's see how we would do this kind of hypothesis test using technology. So we've got a study of 2,000 Canadians. And the question is, when nothing is occupying my attention, the first thing I do is reach for my phone. We found that 77% of the 800 participants aged 18 to 24 responded yes. Do the samples support the claim that more than 75% of all Canadians would respond yes? So let's start with our hypotheses. We made a claim that it's more than 75%. If it's greater than, less than, or not equal to, you always have to put that in the alternative. So what we're looking for is a greater than 0.75. So our null is going to be equal to 0.75. The null is always an equal to. You need the value of x. This is the number of yeses here. And we need the sample size. Well, we know the sample size is 2,000, but the problem didn't give us our x's. It gave us our p hat. So if you need to, if they don't tell you how many out of that sample, oh wait, I'm sorry, sample size is not 200. We're only looking at the 18 to 24-year-olds, sorry. So we're only looking at those 800 people. But if you need to find what x is so that you can use StatCrunch, you just take the sample size times your p hat, which in this case, 800.77, and then round that to a whole number. It's 616 people. That's all you need. You need to set up your hypotheses. You need to know x, you need to know n, and the computer will give us our test statistic and our p-value. So you go to StatCrunch, and you go to stat, proportion stat, one sample with summary. Again, we don't have the raw data, so we go with summary here. Number of successes, that's your x. And so that we had to calculate, but we got 616. And then our number of observations. Then here we put in our hypotheses. So our null was that it was 0.75, and our alternative is that it's greater than. So I just typed that in, and then I click and pick the one that's appropriate. And that's all I have to do. Hit compute, and it gives you the output. The last two things, that's what you need. The test statistic is 1.306, and the p-value is 0.0957. So we would write that down. If a question asks you for the test statistic, you can get it in StatCrunch really easily. You can get the p-value. That test statistic was just finding that z-score from that formula. The p-value was just finding the probability that you would have seen that test statistic. This p-value is kind of big, okay? We don't know what our alpha was, but we'll just assume that it was 0.05. So we do not reject. So here we did not find enough evidence that more than 75% of young Canadians would say yes. So that's what we write. There is not sufficient evidence to support the claim that the proportion is greater than 0.75. And we're done. Whoops, I didn't mean to click through that far. But there we go. Now we're done with that. Now, let's just look at one other way just to think about what's happening here. This is in your textbook. Where these p-values are coming from, you know, if you just absolutely don't want to use StatCrunch, you don't have to. You can do it by hand. And if you are looking at your alternative as a greater than, then what you're looking for is you find your calculated test statistic, and then you find the probability that you are at that test statistic or greater than. If your alternative is less than, then you find your test statistic and you find the probability that it is less than that. So basically it's 1 minus the table value for the greater than, or it's just the table value if it's less than. Now, with the two-tailed test, then what you're going to have to do is you're going to have to find the lower tail and the upper tail. So that's where we already talked about this, but if z is positive, you do 1 minus the table value times 2. So find that 1 minus the table value, multiply by 2. If z is negative, then you do just the table value times 2. But I hope all of you will be comfortable using the technology. Oh, I didn't need to write that. It was right here. Hopefully you'll be comfortable with your technology to just use StatCrunch. That's what it's for. That's, we live in a world where technology is super common. So that's what I encourage you to do. And we're going to do 2 more examples. And we're going to go back to that preview example where we're looking at which gender baby would you pick. So of those 229 women who were surveyed that said that they would like to choose, 89 said that they wanted a boy and 140 said they wanted a girl. So the life science summary, if you recall, said that there was really no difference. So here, they said it's just likely to have a boy or a girl. And so we're just going to let P be the proportion wanting a girl. And life science said there's no difference. So we should, according to life science, fail to reject our null. Well, let's see if we actually do. We need our number of successes. So 89. Oh, no, this is girl. Sorry. 89 was boy. 140 was girl. So 140 out of our sample size of 229. Let's get our test statistic. Let's get our p-value. So let's go to StatCrunch. And I'm just going to change this one. So we had 140 out of 229. And we're looking for, was it half and half, no difference? Or was it actually different? And we see a test statistic of 3.37 and a p-value of 0.0008. So I think life science might have not quite realized what was going on with this problem. That here, the p-value is 0.0008. That is less than even the smallest alpha that we would use. So we should reject the null. And remember, the null said that there was no difference. The null said, hey, it's 50-50. But we just found enough evidence to say, actually, it's a little higher than 50-50. So we're going to reject the null and say that there is sufficient evidence to suggest a preference on baby's gender. I get a little lazy when I'm writing out sufficient. It's such a long word. There's sufficient evidence to suggest a preference and gender. Preference. And so now pretty quickly we can take our sample data and see which hypothesis that it supports. One more example. We have 2,186 hiring managers and HR professionals looking at whether employers were using social networks to screen job applicants. There were 2,186 people in the survey, and 1,312 said yes, they do. So we need to make a note of that. Our number of successes was 1,312, and there were 2,186 in our survey. And so is there convincing evidence that fewer than 2/3 of hiring managers use social networking sites? So what we're looking for is fewer than 2/3. So that goes in our alternative. You always put the greater than, less than, or not equal to in the alternative, and the null is just equal to that value. And let's get our test statistic and our p-value. So we go into StatCrunch, and 1312 is the number of successes, 2186 is the number of observations, and StatCrunch is just fine with you typing in 2/3, and we want fewer than 2/3. So that's all we need. Hit compute, and we get a test statistic at -6.59 with a p-value that is so small that StatCrunch can't even give it to us. They tell us that it's even less than 0.001. So we really had overwhelming evidence that fewer than 2/3 of the people, at least in the survey, who use social networking. So what is our conclusion? We reject the null because we had that tiny p-value. And there is sufficient evidence to go with the alternative. So what does the alternative say? That less than 2/3 use social networking to screen employees. And most of the time, you're just going to pick a multiple choice question here. You're not always going to have to write all of this out. Social networking to screen applicants. But you certainly, in the real world, outside of school where you have things like multiple choice options, if you were in the real world and you needed to draw your conclusion, you would have to put into context what you just found. If you were reading a study, you would need to understand what they're talking about. And so now you can find a research study and they will report the p-value, I assure you. Well, if it was less than a few years old. P-values are under attack. I'm just going to throw that out there. P-values get abused. They're misunderstood. They show up in research and they have no business showing up sometimes. And the p-value is kind of having a bit of a crisis. And what they're doing now is they're also having people report an effect size. Basically, p-values, if you have a large enough sample, your p-value is going to be small. And that's where we just have to be careful when we're looking at these p-values. They also want the effect size, where it looks at how strong our evidence is. So if you were to read a current study, you may or may not see the p-value. It's a whole thing. There's articles in the statistics literature every month. But we're not going to worry about that right now. The p-value is still what we're going to teach. It's still there. It's still valuable. But if you were to do more research, if you were the one producing this data, you would be learning about some of these other things like effect size and how to interpret. So I didn't mean to go down too much of a tangent here, but I did want you to recognize that if you see something about p-values going out of favor, they are. But for right now, we're still going to study them. They're still useful, and I'm going to leave that for your 300, 400, or graduate level statistics class if you end up needing to take one of those.